Hello. Little background. I'm Laurie Segall, the CEO of Mostly Human Media. I was at 60 Minutes before and CNN as our senior tech correspondent. So I love translating tough tech concepts to society. And fun fact, my first interview was as an early junior reporter with Sam Altman, who's now has this thing called OpenAI. And that was like 4 or 5 companies ago for Sam. So tech moves quickly. I'm sorry that we're the last panel between cocktails, so we are gonna make it interesting. We have props, we are talking quantum. I'm very excited for it. So I'd love to just do kind of some quick intros, and I'll just ask you all just some specifics about your background, because real different backgrounds on this panel. Sam, I'd love to start with you. You are a group product manager of quantum computing at NVIDIA. And did I see that you were NVIDIA's first quantum computing hire ever?
That's right. Focused only on quantum computing. So NVIDIA got into quantum computing about 4 years ago. I had been working in the field already at a quantum startup called Rigetti Computing, and then at Keysight Technologies. And it's grown quite fast every year since then.
How big is it now?
I mean, everybody works on quantum to some degree at NVIDIA. Yeah. We're all building the same thing.
Cool. And Matt, I'd love to chat a little bit about your background. You're the CEO of Infleqtion. We've just heard this awesome announcement. What's so interesting when I was looking at your background is before you were the CEO of this company, you were one of the early investors. Mm-hmm. So it was just such a great company that you decided, I'm not gonna be an investor anymore, I'm going on as CEO. What was it?
Yeah, I'd always felt a lot of ownership over Infleqtion because I was indeed the first investor in the company. And so before this, I was a venture capitalist, and you'll meet Andrew in a second, but I worked at Maverick, for a firm called Maverick for almost 18 years. And we're, again, first investor in Infleqtion. If you have a portfolio of companies that you often will have companies that you just gravitate towards and you love and you spend more time with, and Infleqtion was always that for me in my portfolio of companies at Maverick. And so when the opportunity came along to join full-time about 18 months ago, I jumped at it. And so it was certainly not the path of least resistance. I was living in San Francisco. My wife is from San Francisco. We had, at that time, a 4-year-old and a 2-month-old, and this required a move to Boulder. And so, but given all of that and how hard of a decision it should have been, and I loved working at Maverick, it was actually a pretty easy decision. So I love the company, and it's been an absolutely wonderful transition into this role.
Great. And Andrew, you are at Maverick, so this is, a lot of people on the stage are connected in ways that we will soon learn about, but you're a senior partner at Maverick. You've been there for 20 years?
Yep, 21 years.
Wow, 21 years.
The 26th, yeah, 2 days it'll be a 21st anniversary.
Well, and so tell us about the investments that you're making there.
Yep, so Maverick Capital is a 32-year-old investment firm. It invests across stages and across company life cycles and across different industries. And so technology obviously is a very important sector that we focus a lot on. I think introduced Matt to Infleqtion way back when initially, right? Was I the initial?
You did actually, that's right.
Yes. Yeah. And then we actually had invested in, was this Loop at Sam Altman's first show? We were actually the first investors.
Wow.
Or one of the first investors in Loop too. So I probably should just have gone and become like Sam Altman's chief of staff or something, right. Just kind of like followed him on his journey since then. But yeah, so long time Maverick employee and excited to be here. Thanks for having me.
Yeah, I mean, and by the way, Looped at the time, there were the location wars. We weren't sure who was gonna win. It was such a fascinating time. And so to see how he's evolved, I think it says a lot about technology.
I remember working on board decks with him when we were like, I think probably both in our 20s. At that point, so a long time ago.
Unbelievable. And last but not least, Dr. Miwa,
Yes.
Wonderful to have you here. You are a senior manager at Hitachi. You've been at the company for 27 years. Mm-hmm. Tell me a little bit about the work that you've done throughout the years and what you're working on specifically right now.
Okay, I'm Toshiharu Miwa from Hitachi R&D. Why Hitachi doing the quantum computer research? I would like to a little bit explain the history of the company. The Hitachi is a Japan-originated global company. Since its foundation, 1910, our mission is to contribute to society through the original and superior technology and product. Then we are continuing to our mission until now. Currently, we are focusing on the social innovation business to solve not only customer issue, but also societal issue. Then I believe the quantum technology is a promising technology to solve the societal challenges. Then we are trying to develop the quantum computing. Our research team is focusing on the silicon-based quantum computing to realize real industry application in the future. That's our current challenge in this field.
This was touched on earlier briefly, but I'd love, before we get into quantum and AI, and to really look at just pull it back and talk about the difference between classical and quantum computing. If you guys could just give us, someone could give us a primer, maybe Matt, I know you have a prop, and I just feel like it'd be great to bring out a prop this late in the day.
Absolutely.
So, I mean, not to single you out, but opportunity for explanation and prop showing.
You know, this isn't the perfect prop to explain that, but I'll find a way to do it. So, okay, so there are a number of different ways to build quantum computers. You may have heard about some of those today. The way Infleqtion builds our quantum products are using this. And so this here is our quantum core. And it's at the heart of everything we build. And the thing about neutral atoms as a modality is it's highly flexible. You can use it to build things other than just computers. Because at the heart of everything we do are atoms. And our atoms are our qubits. So I often say atoms are nature's perfect qubits, but they also happen to be nature's perfect sensors, as well as nature's perfect clocks. And you can think about the range of products that you can build utilizing neutral atoms as sort of this continuum. And along that continuum is both time and complexity. And so what we've been following, the strategy we've been following, it was the seed investing strategy at Infleqtion, was use this neutral atom technology to build some of the less complex products and actually productize those, get them out into the world, show the world there's quantum advantage in neutral atoms, in things like clocks, RF antenna, and sensors more broadly, and then using that leverage in the model to help you get closer to that crown jewel of the utility scale quantum computer, like we'll build here in Chicago. And so what is the difference between a computer and a classical computer and a quantum computer? So there are so if you think about a classical computer, it all boils down to zeros and ones. No matter if it's the most complex GPU, it's the most complex supercomputer. And so it's always a heuristic for how the world actually works. But the world actually works in quantum. And so if you want to model the way the world works and solve the problems that are kind of fundamental to the way the world works, like how are materials created, how do atoms move, they're really generally called NP hard problems. If you have a limited number of variables, and when you combine them, they start to expand and basically get close to infinity. Those are types of problems that classical computers are just going to always have a hard time solving, no matter how powerful it is. And those are the types of problems that quantum computers can solve quite easily. And so when I think about the future, there's going to be a data center stack that will have CPUs. And just like, which I'm sure Sam will talk about, GPUs got layered on top of CPUs to help make CPUs better. QPUs will be layered into that stack, and problems will be sent into the data center, and they'll be carved up into the parts of the stack that are most suited to solve those problems. And the really sticky NP hard problems, again, will go to the QPUs, but they will sit alongside and amplify the efforts of QPUs and of CPUs and GPUs.
Right.
So how was that?
I thought that was great. I mean, in case it's not my prop I just had a baby 5 months ago, and someone gave me quantum computing for babies. So if they get too inside baseball, you blink twice and we'll have them read this. But no, I thought that was great. And Sam, I know when we had spoken before, you talk about how quantum computers are going to augment supercomputers, not replace them. And so can you talk a little bit about where you see this going?
Yeah, I think that there's a very good analogy to the trajectory of the GPU, which is an accelerator that's good at some very important problems. The GPU didn't replace the CPU. It augmented the CPU and expanded the space of problems that could be solved with computers. and that continues to expand. Quantum computers, at the physics level, the fundamental physics is completely different than what a CPU and a GPU are, but from the perspective of a user, it's another accelerator. It can solve problems that neither a CPU or a GPU can, and so working together with CPUs and GPUs expands the space of problems that computers can solve. So we're very excited about that.
And sorry, go ahead.
Yeah, it's good. The only thing I would add to that is you get caught up in kind of the alphabet soup of all these different technologies. But when we think about it from a tech innovation and cycle perspective, you look over almost like each decade, and there's a new compute cycle. And you look at the 90s, it was really the rise of the PC, and you saw some massive companies get created over the course of that period of time, really with Intel capturing the majority of the value of the compute cycle that drove the PC. And then you kind of look at the 2000s and the rise of mobile, which was another big compute cycle, and companies like Qualcomm and ARM really kind of dominated that cycle as mobile took off. Then you had the rise of the cloud, and beneficiaries there were likes of, again, Intel on the CPU server side and AMD to some extent, and NVIDIA. And then now, obviously, with the rise of AI, NVIDIA being the dominant player there, and you're seeing massive value get created to the point now where NVIDIA is the largest company in the world. And I think it'll be interesting to see how quantum kind of fits into the next compute cycle, because I do think it will kind of be that what's after AI, perhaps. But I think it is more of a complementary technology, not such that it would kind of replace the NVIDIA GPU completely or a Intel CPU. And so, but just kind of thinking about that, pretty much every decade you see these shifts, and we're kind of in the early innings of the AI shift, and does quantum represent the next one?
What do they say behind the scenes with other VCs? I mean, you've been in this for over 20 years.
Yeah.
I mean, are VCs in your business, are folks very excited to invest in, and what type of companies are they looking to invest in when it comes to quantum?
The interesting thing about quantum versus even some traditional AI companies is that you've seen a lot of these quantum companies actually get into the public markets quite early, which is a little bit unusual, because usually when the tech has to be a little bit more proven, so you actually have seen many of them go public early, in part to get more capital that is required to scale these businesses over time. So that's kind of one interesting observation, where there's actually not as many VCs in quantum as you'd think, because a lot of these quantum companies are already public, right? And so you've kind of missed that window to invest in them privately. Now it's obviously much easier to invest in public companies. And so I think from the perspective of what folks are looking at in that earlier stage community, it really is like all the bottlenecks that have been created with these today AI infrastructure builds, and the complexity that comes when you're building a data center that's going to consume potentially a gigawatt of power. It's like kind of unfathomable. Like there was a time 20 years ago when like a 1 megawatt data center was like considered large, and now you have like 1,000x that in size. And so just trying to figure out how to address all of these challenges that pop up when you're trying to put an enormous amount of power and an enormous amount of compute together, get all these chips talking to each other. If you ultimately layer quantum on top of that, that's going to add a whole nother layer of complexity, and just trying to solve some of those bottlenecks, I guess, is how I frame it.
I would like to point out that Infleqtion is indeed still private. So if there's anyone who feels like you just missed the opportunity to invest in quantum, come talk to me.
Yeah. Well, I mean, to that end, Matt, you've said that your mission is to commercialize quantum.
Yes.
I think I saw you said somewhere, to commercialize, quote, weird science. Quantum's been called very strange, bizarre science. Einstein called it spooky. So how do you commercialize this? I know that at one point you said that clocks are in the tens of billions of dollars of opportunity. Like, can you explain that?
Sure. So to Andrew's point, it is interesting to see how the quantum industry has played out, because there has been a lot of capital raised for quantum in general. But for the most part, quantum computers aren't yet adding a ton of commercial value. It's going to change, and that will happen soon, and that's what we've been talking about all day. But the initial seed thesis, and going back to what I was saying earlier for Infleqtion, was could we go a slightly different route, which is use this very flexible neutral atom platform and actually try to bring quantum advantaged products to market along the way. And this is following a pretty tried and true market development commercialization strategy of finding where you can have commercial advantage, monetize that take gross profit dollars from that, put it back into R&D and to move along the way. So we have a bit of a different strategy than many other quantum companies. And that's what I mean by commercialized quantum. And so I think it's really important because you need to get, or I believe you need to get feedback from the market, and you need to learn how to build things in more than ones and twos. You need to engineer systems. And if you're just doing that in a lab, it's challenging to know what that external feedback will be. And so we take the external feedback we get from our more basic products like our clocks or our quantum RF antennas and incorporate that into our R&D engine, which just helps us get better at building the computer, which is the crown jewel or pot of gold at the end of the rainbow or whatever you want to call it. And so yes, the clock market in and of itself is a very, very large market opportunity. And it wasn't until I started going down the precision timing rabbit hole that I realized this. But if you think of just how reliant the entire world is on GPS, it starts to become quite scary when you realize that GPS is increasingly getting spoofed, it's increasingly getting denied, and we have trillions of dollars of infrastructure that effectively rely on 30 satellites that are from the 90s that are circling the Earth. And if you think about what GPS is, it's a PNT system, a position navigation timing system. In reality, it's a lowercase p, a lowercase n, a capital T. So much of the value that we get from the GPS network is in fact that precision timestamp it sends down to Earth. And every financial trade relies on GPS for a precision timing stamp. The electricity grids sync up to GPS. The RF antenna networks sync up to GPS. The list goes, the logistics, the navigation, it all is reliant upon this system. And if that were to go down, trillions of dollars of economic value would be lost. And so clocks, and specifically GPS-denied resilient clocks like the ones we can make, where you can have better than GPS timing locally that is not able to be spoofed or denied, is already and will continue to be a larger and larger market opportunity.
Great. And Dr. Miwa, I know we've talked about the potential of quantum computing, and we hear a lot about it solving these big problems, these real world problems. I know people talked a little bit about this earlier, but I'm curious for you guys, with what you're building, what kind of problems are you hoping that this technology, that what you're building will solve?
Okay. The one very simple question, the nature doesn't operate based on the classic mechanics. It means the quantum computer based on the quantum effect, it's very suitable for the better understanding the nature itself. That's one potential application to understand the very complex and large chemical reaction or very complex biology reaction. We understand the mechanism of these reactions. We can find the new material or new drug to accelerate without any physical trial. That's the potential solution in the future. But it's a little bit take a time to realize the general purpose quantum computing in the industrial use. But that's in the future, quantum computer supports these kinds of next societal issue can be solved.
And going from that, if we talk about artificial intelligence and like where we are now, where we're going with quantum, I saw someone describe, Sam, AI and quantum as the new power couple, which I thought was a nice little way to describe those two things. So if we're looking at this through the power couple, what does quantum do for AI? What does AI do for quantum? How are they going to benefit one another?
Yeah, I guess how I feel about that analogy depends on who the old power couple was. If it's Taylor Swift and Travis Kelce, maybe that means something.
Yes, if quantum is Travis and if AI is Taylor.
I'm glad we got here.
Yeah. I know. I am too. This is probably the only time in history Travis and Taylor will have been mentioned.
No, I think Matt said it well at the beginning. Quantum and AI are going to work together. Quantum is going to enhance AI. We expect that quantum computers can be used to generate new types of training data that are a better representation of the physical world, that can be used to train models that are a better representation of the physical world. And AI is already enhancing quantum at every level, from the chip all the way to the user. AI is being used to control, calibrate, correct errors in a quantum computer, to develop better algorithms. And from the user perspective, AI is going to be hugely impactful for growing the quantum workforce. If programming a quantum computer looks not like learning a new assembly language, but like telling a model, use the quantum computer to accelerate this part to help me solve the chemistry problem. All of a sudden, a lot of people can use quantum computing. So we really see a symbiotic relationship going forward.
I mean, it's interesting you bring up this idea of synthetic data, right? Like when we talk about the future of artificial intelligence, one of the biggest things is where are they going to find the training data? What kind of data is it? And so I'm curious when we talk about how this could help create synthetic data. Can you get into that a little bit more?
A little bit more, yeah. Quantum computers, I think was said at the beginning and has been said a few times, are better at modeling the way the physical world truly is at the lowest level. And so if you are trying to use an AI model to solve problems related to the physical world, to design new drugs, to develop new materials, to understand chemical reactions, you may want to train on data that's as good a representation of that world as possible. And so, an exciting use case for quantum computers is being used to generate that data to enhance models for the purposes of solving those problems.
Matt, one new approach Infleqtion announced this year was a partnership with NVIDIA, this contextual machine learning type partnership where you're using quantum computing principles to enhance artificial intelligence. Can you tell us a little bit more about that?
Sure. It turns so when you write software for quantum computers, you have to code it in a different way because you actually have to code around some of the underlying laws of quantum mechanics. There's these strange things like the no-code theorem where you can't copy and paste quantum data. Copy and pasted data is a big part of classical software. And so you have to kind of re-architect the way the memory is shaped. It turned out when we apply that to GPUs, that quantum data, it actually shows some interesting performance enhancements of GPUs, especially around some of the critical bottlenecks of GPUs, like context windows. And so by applying this quantum-inspired software, call it, on classical GPUs, you can actually see performance increases. So that's just one way. There's it's not really a quantum thing, but it's quantum software that was written for a quantum thing applied on GPUs, which does actually increase the performance. I think I'll add two things to what Sam was saying. In terms of more synthetic data, you can also just think of quantum sensors as generating vast amounts of data. And so instead of having to create synthetic data, we can just expand vastly the amount of data we could put into AI systems to help train them and at precision levels never really before possible. So that's one other symbiotic relationship between quantum sensing and AI. And then I'll just point to an application that Sam and his team and the Infleqtion team worked on together back in December, which is a very basic but good example of how GPUs and QPUs can work together. And we solved a very basic, it's called the Anderson impurity model, which is a material science algorithm that was done partially on our logical qubits on our QPUs, but largely on GPUs. And it's, I think, a little bit of a vision of the future of how they might work together going forward.
When we think about artificial intelligence, it was here long before ChatGPT launched in 2022. But ChatGPT was almost this commercial wrapper that just started this race to some degree. Will quantum have a ChatGPT moment? Can you envision what that would look like? Andrew, hot seat?
I kind of want to hear what they say first, and then I'll opine on
From
it.
an investor standpoint, okay, we'll go to you guys first, and then.
We'll go this way? Yeah, we can each take a crack at the answer.
My background is R&D guy. I don't expert in the financial or the investment side. But anyway, the current quantum computer required special the knowledge to design the how to model to you quantum computer understand how to do that. That's maybe the like a ChatGPT in the future. The AI supports utilize the quantum computer without any difficult mathematical knowledge or any other with less the domain knowledge. That's in the future the AI will evolve towards adapting the quantum computer. That's my
Great.
opinion.
Great.
So if we're trying to map, and I guess it depends on what do you mean by a ChatGPT moment, but if it's the moment where people realize, oh, this is valuable to me or useful to me, it might not be as in your face as being able to interface with an AI model that passes the Turing test, which was whenever any of us use ChatGPT for the first time, it was like a life-changing experience kind of. But if it's, oh my gosh, like quantum might actually be useful to me at some point, I do think we will have that moment, and I think that moment is in the not too distant future. And one of the reasons why I think that is because, if we're going to stick with this analogy, before the ChatGPT moment, several years earlier in 2017 or so, there was a paper written called "Attention is All You Need," and that was basically laid out, how you build LLMs, and that ultimately resulted in ChatGPT. I do think we're past the "attention is all you need" paper in quantum, and so the next step is and that was the announcement of logical qubits at the end of 2023, which logical qubits are, I don't know if we've learned this today or not, but they're error-corrected, pristine qubits that can actually be used for calculations. And so whenever someone says qubit, you have to ask, are they talking about a physical qubit or a logical qubit? Logical qubits are actually what you need. And there'll be a ratio from physical to logical qubit based on the quality of the physical qubits and then the error codes that are run on those physical qubits to create logical qubits. And so we have logical qubits. We have the groundwork for the ability to do things that one might consider a ChatGPT moment. And so next step is that. And so I do think we will have a moment like that.
I don't know if quantum will have a ChatGPT moment. I think, breakthroughs like that by definition are impossible to predict. I think one kind of important takeaway and optimistic takeaway from ChatGPT is, AI was already being used for a lot of applications and was valuable before ChatGPT, right? It was in recommender systems and many other applications, and then ChatGPT just took it to another level. And so, today we're all talking about the first useful applications of quantum, and so, maybe we can take away that the long-term potential might be undersold. We're going to have the first useful applications, but there could be a moment beyond that where it gets way more useful, even than people might have imagined, looking forward. So that's what I hope.
Yeah, I think when you go back through this, that compute cycle analogy, and if you take mobile, right, you saw kind of like the early inklings of what mobile could do when the BlackBerry first came out, right? And then it was really like that iPhone moment when it was like, oh my gosh, this is can completely change like how I interact with, whether it's internet or I don't say social media, but just all these different interfaces that were kind of all consolidated onto one device was kind of this aha moment. And then, with prior to the ChatGPT moment, right, you saw like these inklings where if, initially it was like a grandmaster in chess was beaten by a machine for the first time, or when the Google team beat Go, that you guys know what I'm talking about, right? The game that was, thought to be very difficult to crack from a computer perspective. And then, I think with quantum, I think you'll see some early signs right then there. I think there could be some. I wish I knew exactly if I knew exactly what it was.
You'd invest in it.
Yeah, probably. And I don't know if that's noble right now, but I think there probably will be, because you've seen that with prior, cycles with computer, even with when the personal computer came out, right? When Windows 95 was like the first graphical user interface, and it was like, oh my gosh, I can interact with this PC in a much simpler way. So I think that you tend to see that, you have historically. So I'm not really sure why that wouldn't happen again.
It's having a 5-month-old and watching. I'm sure folks who have kids, it's just pretty unbelievable to think about what the world is going to look like that your children are going to grow up in. And I know you guys spend a lot of time in computers, chips, and all sorts of stuff that are written about in this book, Quantum for Babies.
It's a really good book. I have several copies.
I mean, it really is a good book. It is really well done. I mean, I feel like they could have done a little bit better at the end. I want some more, like, whatever. It's a storytelling thing. But when I think about my son, Charlie, like, and when he's 25, you know, like and I know it's hard to look out into the future, but if you could paint a picture of like what this is going to mean for real humans, like for our children growing up in the world, especially with AI as an accelerant for all the things that quantum can and could be, what does that world look like for my son? And you have to answer it specifically, because now I've brought my kid into the whole thing, you know? Sam, why don't we start with you?
Yeah, I mean, I think it maybe touches on the ChatGPT moment question. What we're all hoping for from quantum computing is, you know, all of a sudden, or at least over time, humanity's capacity to develop all kinds of drugs, to develop new materials, to solve some energy efficiency problems, has dramatically increased. And so, I think it will look like, computers are now capable of solving a bunch of really important for humanity problems. And so hopefully your son and my son and all of us will benefit from that.
Right. How about you? What do you think? I mean, it certainly seems like with artificial intelligence and quantum and the ability to accelerate so much progress, there's also, when I think about the future, there's also going to be security issues. And I know this was touched on earlier. So I would say there will be new cybersecurity threats, and AI will likely accelerate that. So I'd love to get your take. I mean, you are investing in all sorts of different types of companies. I mean, what is the threat that will arise from this, I would say, power couple marriage?
Yeah, it's an important question. And just thinking about, a security system, platforms that are out there today, whether it's security from a software perspective or hardware perspective, was really built like in a pre-quantum world. And so all of a sudden, if you have quantum computers that are much more powerful and able to crack kind of security systems that were just never even conceived to compute power that powerful, that's I don't know if it's scary, but it's something that, companies today are already getting ahead of, right? This is something that like NVIDIA is thinking about in its future architectures, having, post-quantum security, right? And making sure that they have systems in place to protect against, breaches in the road. I mean, I don't want to say it's kind of like a Y2K dynamic where like, everyone was, paranoid about what was going to happen when the clock struck midnight at the end of the millennium. But like that, it is like that type of dynamic where people are trying to get ahead of this to prevent there being some sort of, at least hacks on very secure systems.
Right.
So,
Dr. Miwa, I'm curious if that's something you guys are thinking about.
Yeah, it's a very difficult question, but I'm not an expert in the cybersecurity area, but the quantum computer is not designed for the code programming. It means just the quantum computer is based on the quantum physics. It means if the optimistic way thinking, the security expert understands how quantum computer works correctly. I believe the cyber security expert improve or update the current the problem to fix it for the next coming quantum computing. That's I think the too much worry about the quantum computing, the capability in the cybersecurity field. That's an optimistic way.
Right.
Yeah, it's sort of a mixed bag, and I'm optimistic as well. Quantum technology can be used to distribute keys more securely, can be used to generate random numbers more securely, can be used to create more secure types of encryption. the threat of quantum computers to existing encryption is real, but I'd say it's well understood. Quantum computers are good at factoring large numbers efficiently. We can design protocols that are not based on that and are based on problems that are also hard for quantum computers. And it's a big logistical challenge, but it's a well understood one.
I know that. Oh, sorry. Go ahead.
I was just going to say, just so everybody, I think everybody gets it, but the whole RSA encryption is based upon a critical inability of classical computers, where if you were to give it two numbers and say multiply that together to give me a very long string of numbers, that's very easy for a classical computer to do. But if you were to try to reverse engineer that process and say, here's a very long string of numbers, give me the two prime numbers that would multiply to reach this number, that's one of those problems we were talking about at the beginning, where it would just have to try every single possibility, which would take like the life of the universe to do. And so that seemed very logical to base your encryption system on, and something that a classical computer couldn't do, and it was very difficult to see a world in which it could do that. That is the type of problem that a quantum computer could solve, because it's one of those things where it could simulate all the different possible answers very quickly. They can't do that yet, and to calm people's nerves, this is actually one of the harder things for a quantum computer to do, so we will need a lot of logical qubits to do that. But the interesting thing, though, is that a lot of data has been historically encrypted this way, and a lot of data has been stolen from one country to another and vice versa, and is sitting in servers. It's called harvest now, encrypt later, and they'll be able to encrypt that data later on when the quantum computers do get to that point. So I'm totally optimistic on the future. We will figure out new encryption methodologies, but if anybody encrypted some things that they didn't want the world to know about 10 years ago, that might get decrypted at some point.
I know that I would love to chat a little bit more specifically about what you're doing at NVIDIA and how you're supporting other folks who are building out quantum. I saw something you said about how you guys are supporting, you're not building the self-driving car, but you're supporting folks who are actually trying to build that. Kind of like always the bridesmaid, never the bride, not in a bad way, but like you're there to support. So can you talk about some of the programs that you guys have launched to actually be able to give other folks the capacity to build out in quantum?
Yeah, so quantum in just about every way is a very natural thing for NVIDIA to do. NVIDIA is a platform company. I probably said we're not building a self-driving car ourselves, but we're helping everyone who does. We're not building a robot ourselves, but we're helping everyone who does. We're not building a quantum computer ourselves, but we're helping everyone who does. The things that we bring are the best accelerated computing and AI have to offer. Classical computers are great for simulating quantum computers for the purposes of developing better algorithms and for designing better quantum computers. They're great for training AI models to control, calibrate, correct errors in the quantum computer. They're great for the non-quantum side of hybrid algorithms because every useful quantum application is going to be hybrid. And so we've built platforms for all of that. We've built libraries on our GPUs to make simulation as fast as possible and as easy as possible for the user. We've built the quantum analog of CUDA, which we call CUDA-Q, which is an open source qubit agnostic way to program quantum computers as an accelerator to take quantum chemistry or AI applications and add quantum to them, working together with CPUs and GPUs. Was the platform that Matt talked about in the great work Infleqtion did last year that was enabled by CUDA-Q. And we've built a system for tightly integrating quantum computers and supercomputers so that people can start to run hybrid applications with real performance benefits.
Do you want to explain what CUDA is to everyone? Because it's like another one of these like acronyms or buzzwords that get thrown around. It's obviously a very important part of your business.
Yeah. So before CUDA, GPUs were mostly used for, as the name implies, graphics and video games. Some very smart scientists realized that the same math that made a good graphics processor could be used for a lot of other important computing applications. But you had to be kind of a pretty clever hacker figuring out how to program your own, program these, they're called shaders, to solve this. And what CUDA did is it made it so if you could program in the programming languages anyone was using, C, C++, Python, you could use a GPU very easily. So it's a programming model, it's a compiler. Today, it's underneath nearly every important AI or scientific computing application. So it kind of brought GPUs in as a first-class citizen into computing. So CUDA-Q, we hope to do the same thing with quantum computers, bring them into every useful computing application.
Right.
Just a plug for Sam and his team. Any quantum companies here should work with them. They're fantastic.
Andrew, I'd love to go back to the investment side. I mean, what signals? You hear a lot. How many pitches must you hear a year?
A lot. We track it. It's hundreds.
Okay.
And there's kind of different levels of depth you'll go with the company. Sometimes you'll just see kind of an overview presentation and not even do the meeting. Other times you'll do kind of a introductory meeting, and then kind of you'll continue to peel back the onion the more interested you are in the opportunity.
Right.
And a lot is a short answer.
So you see a lot. When it comes to quantum,
Yeah.
What signals are you looking for in a quantum startup that this isn't just cool science, this could be real business?
Yeah, I mean, I think like the most powerful signal for us, whether this is quantum or other areas, is like trying to get feedback from actual customers of the product or potential customers of the product. And so I think a lot of companies, you look at a PowerPoint presentation and it seems great and on paper is very exciting, but then it's really the folks who will be, buying that product that are ultimately going to define the success of that startup itself. And so what we've found most instructive, and there's other pieces to the diligence process, but I think pretty much consistently, like getting that customer feedback where you can understand like what's working, what's not working, and what the opportunity could be, is what we've found to be most valuable. And that's how we kind of, really is our North Star.
Great. I want to do a little lightning round as we kind of near the end. So you can answer quickly or not, that's up to you. One prediction from each of you. Let's say the breakthroughs come, commercialization happens, quantum is here to stay. One big quantum prediction in the next 20 years, what's it going to be?
I would say quantum, it kind of amplifies and accelerates the pace of AI improvement by, whether it's generating more data or something along those lines, but is kind of a real amplifier to the trajectory on it. Do you get like a bend in the curve such that the intelligence of these models even increases at a faster rate?
Great. What do you think?
I think we're going to find that to make quantum computers work as well as possible, we're going to be really tightly integrating and co-designing CPU, GPU, FPGA, along with quantum computers. And so it's really going to become a bunch of different processors that we talk about as a single computer solving these problems.
Great.
Before I answer, I do just want to say that they're fun questions to answer, but they're very hard to get right. I just only because I remember 15 years ago, Andrew and I trying to size the market for NVIDIA GPUs, and at that point they were mostly in games. Never would we have thought that the most transformative technology would be based upon them, in the form of LLMs and AI. So that said, if we're on a 20-year horizon, we've got a lot of room to work with there. So I think we'll see our ability as humanity to discover and create brand new materials that are like strong as steel, but much more efficient, better batteries. So lots of things in the material science world, a lot of ways to improve the drug discovery process. These are all problems that are well suited towards quantum computers. And so generally speaking, it's kind of underneath that broad chemistry umbrella. And if you think about what percentage of the global GDP that makes up, it's a very, very large percentage. So I think you'll see very transformative impacts. Will you be able to trace that back to quantum? I don't know, but I think we'll be, it'll be an enabling technology to allow us to do a lot of those types of things that we just haven't really been able to do or even imagine because that technology just didn't exist.
What do you think?
Okay, I add Matsu's comment. But the important thing to realize quantum computing, one is the scaling technology. It means the digital computer, like Moore's law, also the current generative AI acceleration, the scaling up is very faster than other computing technology. If we found out the breakthrough technology, how to scale up the quantum technology, it's a case the quantum technology very close to the real the implementation to the society. Our researcher always looking for this kind of breakthrough technology, but still looking for this kind of technology phase.
Great. Matt, you get to ask physicists wild questions. You said this on the call. You get to ask physicists wild questions all day, every day. So what is the strangest, weirdest question you've asked in the rabbit hole that you've gone down? We can get weird because it's the end of the day.
Right. Well, I suppose, there is a fun game we play because every day I walk into the office, the average IQ plummets because I work with the smartest quantum physicists on the planet, and I am definitively not that. So I do get to ask very basic questions to the quantum physicists, to the extent of, tell me about quantum tunneling. Oh, if I were to run against that wall, would I end up on the other side of the wall? And the answer is yes. If you did it a trillion times, there is a scenario in which you might end up on the other side of the wall. Or could I be in superposition? The answer is yeah, technically I could be in superposition in certain probabilities. So that is the fun game I play. But what is the most mind-boggling concept? To me, entanglement's the most mind-boggling concept. It just is hard to wrap your head around and as to why or how that would happen. And I know I'm in good company because Einstein thought it was really, really weird also. So entanglement is my answer. But a lot of it, so much of quantum mechanics is mind-boggling. If you start to think about it is, all of it's mind-boggling.
And folks here, I know we have quantum curious, quantum pros. How many folks know entanglement? And okay, great. This takes me to my other question, Sam. You're at the Thanksgiving table. Grandma's there, your uncle who's down the rabbit hole on Reddit on quantum, your siblings, your parents, and they want you to explain entanglement to them in the terms that you can't leave grandma behind. She needs to know. How do you explain it?
You asked ChatGPT, right?
By the way, exactly. I did ask ChatGPT, and ChatGPT gave me something called the soulmate analogy, but I'd like you to go first.
Oh yeah, back to Travis and Taylor.
Yeah, all roads lead there.
So entanglement is like if we had two coins, and they could be heads or tails, but if one was heads, the other had to be heads, and if one was tails, the other had to be tails. So they shared a state, and I gave you one, and we didn't look at whether each one was heads or tails, and you went to the other end of the universe, and then I looked at mine, and I saw that it was heads. Yours immediately would become heads, and it's not that it was heads before and we just didn't know. It's that somehow this shared state collapsed to one of the two outcomes. So that's the part that's pretty hard to wrap your head around. What's going on for Einstein and all of us, and the fact that we can take that and harness it and build a computer that can solve useful problems is pretty amazing.
And just to be clear, ChatGPT said, imagine two people, Alice and Bob, which apparently there's Alice and Bob who are soulmates, and whenever Alice feels happy, Bob feels happy. And if Alice feels sad, Bob gets sad, even though he has no idea why. They're emotionally in sync. And the quantum twist is she's in a state of happy and sad at the same time, and the moment she checks her emotion, there's a whole thing. And honestly, it sounded more like a toxic relationship to me, but I thought it was a very, very interesting way to describe some of these things. So thank you for sharing that to Grandma and everyone else on this stage. I know we have to wrap, but I'm curious because this is such a fascinating topic and such an extraordinary thing to spend your time on. It's really not like, if my son Charlie decides to go into quantum, I'll be very proud. It's not an easy challenge, but a challenge nonetheless. I'm curious why this work is personal to all of you guys. You spend a lot of time on it, so.
Yeah, I think it goes back to kind of what could be those breakthroughs over the next 20 years, where I feel like, at least from a semiconductor standpoint and quantum standpoint, this is some of like the most critical building blocks for like the future of the economy, for the future of healthcare, for the future of just mankind. And so like to be at like that fundamental infrastructure layer that's really supporting everything, I think is meaningful.
Great.
Well, I got into physics before it was possible to get a job in something like this, and so the whole reason I'm doing this is personal, and it goes back to, I think, the very last question, like taking this just kind of fascinating set of things about the universe and starting by learning as much as I can about it, and then try to use it to build meaningful technology that can solve important problems. Seems like a great way to spend one's time.
Right. Matt?
For me, I think it is it's really important for all of humanity to figure out how to harness these quantum mechanical properties and build products out of them that can kind of bend the curve on progress. And so it's a really inspiring mission to be pursuing that. And so that's kind of personally why I did leave a really good career and a great quality of life to come do this, because I felt like it was sort of my one shot to be part of something potentially really great and amazing. And so I feel really lucky to be doing this every day.
Dr. Miwa, why is this personal to you?
Okay. For realizing quantum computing, the engineering and the systematic technology is important, but also very important thing is fundamental physics is still important, because there are so many unknown factors in the quantum computer area. I would like to need more collaboration with the private sector and the academia side to accelerate the development of quantum computing. That's important things from our private company side.
Great. Awesome. Thank you guys so much. Thank you guys.
Thanks, everyone.
Thank you.
Bye.